All right, we are going to be converting from scientific notation to standard form. That should say form, not from. So let's put that in. Standard form. And that's week 5 of Math 208. All right, so when we write something in standard form, they just want us to take this number and this, essentially think of it like a multiplication problem, and they just want us to write it in as an answer. That's basically what standard form means. So if you think about this problem right here, this really means 8.76 times 1, 2, 3, 4, 5, 6, 7. It means we're multiplying by a number with 7 zeros. That's what 10 to the 7th power means. If you think about it, 10 to the first power means 10. 10 to the second power means 100. 10 to the third power means 1,000. So basically what you should see is that whatever the exponent is, that's how many zeros you have in your number. So when it says 10 to the 7th power, I needed to write out a 1 followed by 7 zeros. 1, 2, 3, 4, 5, 6, 7. All right? Now, when I multiply 8.76 times 10 to the 7th power, this big number, I don't know what the heck number that is, 10 million. So when I multiply 8.76 by 10 million, is this number going to get bigger or is it going to get smaller? Well, it's going to get bigger because you're multiplying it by 10 million. So the way you take a number and make it bigger is you take its decimal and you move it. You take that decimal and then you move it to the right 7 spaces, because that's how many zeros we have here. All right, so when I take this decimal, which used to be right here, and I move it to the right, that means I'm going to have to move it over 7 spaces, but I'm going to have to add zeros because I don't have enough digits here to move over 7 spaces. So I'm going to have to move it over 7. So I'm going to get rid of that little decimal because that's going to get confusing. And I'm going to start here, and I'm going to move over 7 spaces. 1, 2, 3, 4, 5, 6, 7. So that's where the decimal ends up. And I need to fill in some zeros right here because that's what's needed. So this is your answer. And basically, I'm going to get rid of all those little loopy loops. And the answer is this. And if you really wanted to know the answer, you put commas and say, oh, look at that. The answer is 87,600,000. Now, when you're entering in the answer, I don't think you need the commas. So, in fact, I would recommend not putting in the commas as my first attempt at putting in the answer. I would just say, here is our answer. So again, we're writing the expression in standard notation. So that's another way of saying just write the answer, the standard form, all right? Oh, wow, look at this. They have the word from. Ha ha, they misspelled. Okay, so anyway, I just noticed that. Okay, so anyway, what do we have here? So first we've got 2 times 10 to the negative 2nd power. So we need to know that technically speaking, this means it's 2 times 1 over 10 to the 2nd power, okay? Now that's technically what that means. And really this means 2 times 1 over 100. And if you wanted to, you could say 2 over 100, and that's equal to 0.02. All right, now I just did all that in expanded notation. Actually, believe it or not, using a bunch of this stuff right here. When we take 2 times 1/100th is equal to 2 over 100, which is equal to 0.02. That's 4th grade, believe it or not. So anyway, but here's a nice little shortcut when we are in scientific notation. So the idea is, I'm going to copy the problem down. We know that when you're multiplying by 10 to the negative second power, that's a fraction. And what that means is, even though you're multiplying, it means you're going to make this 2 smaller because you're multiplying by a fraction. So when you take that 2, and you need to know that you're going to take that 2 and you're going to make it smaller. In this case, we know we're going to make it smaller by 2 place values. All right? So this 2, this negative sign means it's going to get smaller, and the fact that it's a 2 means it's going to get smaller by 2 place values. So when the decimal originally started here, all right, because when you don't see a decimal, that means it's in the back, all right? Kind of like 5, you could say like $5 is the same thing as $5. So when you don't see a decimal, there's a decimal at the end behind it, all right? This is in the back. A lot of people think that's in the front. No, no, no. You say that's the back, okay? All right, so we know that there really is a decimal back here behind the 2, and this says we're going to make it smaller by 2 place values. So I'm going to go over to the left 1, to the left 2, because that's how you make a number smaller. So I'm going to go to the left 1, to the left 2, and that means I have to add a 0 right here because I ran out of space. So my answer is 0.02. Now traditionally we put a leading 0 right there, but that's not absolutely necessary. If you wanted to, you could just write you could write just 0.02, or you could write 0.02. Your choice. They both work. Standard form again. So let's write this out, but this is going to be pretty darn easy. So we got 5.619 times 10 to the negative 8th power. So I'm going to write it way over here, 5619, and actually our point goes right here. All right, there's the point. That's the decimal point. So now what does this negative 8 mean? This negative 8 means our number is going to get smaller by 8 place values. So I'm going to take this decimal, and the way you make a number smaller is by moving it to the left, the decimal to the left, because now you're making the number smaller. And I need to make it smaller by 8 place values. And since I run out of decimals, or digits, I mean, I'm going to have to start adding zeros. So I'm going to take this decimal, and you know what, just get rid of it. We don't need it. And I know I'm going to take this decimal and move it over to the left 8 spots. So that's going to become 1, 2, 3, 4, 5, 6, 7, 8. Oh, dang, I ran out of room. I crossed over that equal sign. Sorry about that. So we're going to fill in all these little blanks, these spaces, with zeros. So really, this is our answer. And so I'm going to put, let's get a little nicer. We have, oh gosh, how many zeros? 1, 2, 3, 4, 5, 6, 7. We have 7 zeros. So that's going to be 1, 2, 3, 4, 5, 6, 7 zeros, followed by the 5619. And that is our answer. If you want, you can put a leading 0 in front of the decimal, but you don't have to. All right, last example, writing that number in standard form. And when you write that number in standard form, first let's write the problem. So 7.8 times 10 to the 7th power. So the idea is, now because we're multiplying by a positive exponent, that means we're going to make this number bigger by 7 place values. All right, so let's write that 7, 8, and where does that decimal? Well, the decimal originally started right here. And then because we are multiplying by a positive 7, like a 10 to the positive 7, we know we're going to make this number larger by 7 place values. So it's going to go to the right 7 places. So we're going to have to add zeros because we're going to run out of digits. So let's get rid of that silly decimal place. And we know we're going to start here, and we're going to move over. 1, 2, 3, 4, 5, 6, 7, and that's where the decimal goes. So we have to fill in these gaps with zeros. So our answer, without those little loopies, is 78000000. There's our answer, and technically the decimal is at the end, but you don't have to put the decimal at the end. And so our answer is, I don't know if we are going to actually do like decimal or commas, comma there, comma there. So that answer is 78 million, but don't put in the commas. In fact, you probably don't even need to put the decimal point there as well. So that wraps up this whole video.